We like to start our examples and definitions of acids and bases with simple things, with HCl, NaOH, the Arrhenius definition, or hydrochloric acid and ammonia for our Bronsted-Lowry definition. There's lots of different acids and bases with lots of formulas and lots of properties, and it's fairly common for a acid to have more than one hydrogen in its formula. And when we're thinking about those hydrogens in the formula, it's important to recognize or kind of distinguish, is this hydrogen going to be able to dissolve into solution? Is it going to be able to be donated? Any acid that has more than one hydrogen ion that can be donated would be called polyprotic. If it has two, it would be diprotic. If it has three, it would be triprotic. But polyprotic is our general term for many hydrogen ions that can be donated. But when that happens, not all of the ions fall off or are dissociated at once. It's a one step at a time process. And that really makes sense when we do it in terms of the Bronsted-Lowry definition. So phosphoric acid is a great example. The H3PO4 can give away a hydrogen that would make water a base, turning into hydronium, our conjugate acid, leaving us with dihydrogen phosphate, or H2PO4-, a conjugate base. But that H2PO4- still has a hydrogen ion. So if that H2PO4-, the dihydrogen phosphate, comes into contact with a water, this is more acidic than that. It donates its hydrogen ion, once again making a hydronium, and a hydrogen phosphate. That hydrogen phosphate still has a hydrogen ion bonded to the phosphate anion. When it bumps into a water molecule, it can give that away, making hydronium and leaving us with the phosphate. So this is a one step at a time process, but is showing that we can donate more than one hydrogen. And in doing this, we're also seeing how this could go backwards. That could be acting as a base, or here it could be acting as an acid. So depending what the ion itself is reacting with, dihydrogen phosphate might be acting as a base, it might be acting as an acid. So we really need to know more about our acids and bases, what these K values mean, what their strength means, and how we can predict and explain that.